Okay, for number 20, this always made me, it's kind of pissed me off. When we got to exponents that were negative, everybody just kind of freaked out. And just because they're negatives or they're fractions or maybe they're variables doesn't mean we don't use the same rules. I mean, why would we want to discriminate against a number just because it was negative or a fraction? So if we have 5 to the minus 9th times 5 to the 6th, these bases are the same, so we can add these, and minus 9 plus 6 is minus 3. So just stop this madness, please. This is raising something to a negative power moves it into the denominator or the numerator wherever it wasn't. So this would be 1 over 5 to the 3rd. And the answer is D. So number 21, solve this system. So we're going to take these two bits of information and we're going to try to solve this mystery here. It's set up exactly for substitution because it gives us y, and we can substitute that information for y into the first equation, and then we'll just have x's. So here we go. So it's 3x plus 2. Instead of y, I'm going to put what we know y to be is minus x plus 5, right, equals 11. So this is, we have to make sure we distribute this positive 2 correctly. We have 3x minus 2x plus 10 is equal to 11. I'm going to do 2 steps at once here. I'm going to combine like terms to get x, and I'm also going to subtract 10 from both sides, and I get x equals 1. And the answer has to be D. That's the only one that is x equals 1, but you should also go back and plug this x equals 1 into the one of these equations. Either one will do. The lower one is the easiest one because we get y is equal to negative x plus 5. We just found that x equals 1. When we put 1 in for x, we get minus 1 plus 5 is equal to 4. Bingo. Number 22. For a recent concert, an adult ticket cost 10. Child's ticket cost 6. Total of 1,000 tickets were sold. The total receipts were this much money. Which of the following systems of equation best models the situation? Okay, so they're telling us what Ms. Blumenfield's telling us that A is the number of adult tickets and C is the number of children's tickets. Well, first, look, A and C have to add up to 1,000. A plus C has got to equal 1,000. And how much money was brought in? 8,760. Right? And if A adult tickets were sold, $10 times A is the amount of money they got for the adult tickets, and $6 per child ticket. That means they got $6 per child ticket. Well, this expression 10A plus 6C better equal 8760. And let's see. A plus C has got to equal 1,000. So, well, that's the answer. Number 23. By what number could you multiply the second equation of the system shown at right to solve the system by elimination? So we're looking at this equation right here, and we have a just scanning back and forth. Just let your mind kind of bounce back and forth between these two equations. We have 7x and 9x, and that's kind of a bear. because they don't have a lot of factors in common, but we have minus 3y in the top and a positive 1y in the bottom, so that equation I want to multiply by 3. That's times 3 to get a positive 3y, and then elimination will take us home. Simplify this, a to the 3rd over b to the 7th to the 4th. Well, I would rather simplify something else first. Let's do a squared over b to the 3rd squared to know exactly the right rules to use here. This is a squared over b cubed, right? And times a squared over b cubed. And that's going to have a total of a to the 4th over b to the 6th. So what did we do? We sort of distributed these we multiplied that times that and that times that, 2 times 3 to get to 4 and 6. So this would be a to the 12th over b to the 24th right there. Am I gonna... I think I have time to paste some more in here, so we're up to 25. Oh, 25's a good one. 25's a good one. Mark my words. As you will see this again. 25 is so good that I'm just excited thinking about it. We have absolute value of x minus 3 plus 11 is equal to 9. Well, when we subtract 11 from both sides, I'm still on orange, we get absolute value of x minus 3 is equal to minus 2. This is great because you cannot take the absolute value of anything. There's nothing in the world, nothing, whose absolute value is negative. Nothing. So as soon as you get you isolate your absolute value term on one side, and if you have that's equal to negative anything, your answer is no solution. And you can even cross it out like that. Graph and solve 9x plus 7 is less than or equal to 5x plus 3. We did that one already. So maybe we could do one more. Oh, that graph doesn't look like it exists. And oh, this is a great one. Okay, this is another fundamental counting principle. 8 people are entered in a race. If there are no ties, how can the first 2 places come out? So we always drew first place. Let's draw a podium like that. And second place. So here's first place and here's the shameful second place. And there are 8 people total, right? So in first place there are 8 possibilities, leaving 7 possibilities for the second, and we multiply these out, and the answer is D, 56. And I am done with that one, and I'll be right back.